All right, everybody, thank you for coming out today. I've had a request if you're sitting in a row, if you could scoot into the middle. We've still got people coming in. We don't have enough chairs. If you could just make a bit of room, I'm sure people would appreciate that. My name is Rowan Miller. I work as a program manager on the Entity Framework team at Microsoft. The topic of our session today is Entity Framework 7. So I just wanted to set some expectations about the session before we start. First of all, this is listed as a level 200 session. So that means, first of all, it's not a 101 introduction to Entity Framework. If you haven't used EF before, hopefully you'll still get a bit of information out of the session, but it's not going to be an introduction to EF. It's probably going to make more sense to you if you've used EF or at least sat in sessions on Entity Framework before. On the flip side of that, it's also not a level 400 session. It's not a deep dive. We are going to spend most of the time in code, but we're not going to be digging into the super technical bits of EF7. This may seem obvious, but this is a session about EF7, which is in preview at the moment. So this is a forward look at what's coming out in Entity Framework in the future. It's not a look at our current stable releases. If you want info on stable releases, there's lots of sessions and videos and documentation online that you can take a look at. And I've got some links for you at the end where you can head for stuff like that. Our agenda is very simple. We're going to spend a couple of minutes in slides talking about what EF7 is. If you've been in an EF7 session before, you've probably seen this content. Don't stress, it's only a couple of minutes, and then we're going to dig into demos. Most of the demos I'm doing are new, things I haven't shown before. And then at the end, we'll wrap up with some places you can head to if you want to learn more about EF7 or get involved in the project. So the tagline we've been using for EF7 is new platforms and new data stores, which sounds great on a slide, but let's talk about what that actually means. So on the new platform side, historically EF ran on the full .NET framework, and that meant you could use it in places such as WPF, WinForms, console applications, and ASP.NET. In EF7, we're opening up a whole bunch of different platforms. This is the same message you've been hearing from a whole bunch of teams at this conference. You'll be able to use it on ASP.NET 5. Now, ASP.NET 5 targets the full .NET framework, but it also targets .NET Core. EF7 will run in both of those scenarios. Because we target .NET Core, you'll be able to use EF7 against .NET Core on Windows 10 Universal Application Platform, on Mac and Linux. And, of course, Mono is also available on Mac and Linux, so you can use EF7 targeting that as well. The point of this slide is we're aiming that you can use Entity Framework wherever you would be writing .NET code. Now, of course, not every provider is going to work in every situation. So the specific providers that are available will differ depending on what platform you're targeting. The other part of our tagline, new data stores, historically EF has just been about targeting relational data. But in EF7, we're opening it up to also target non-relational data stores. Now, I want to be very clear. This is not about building some kind of magical framework that hides the type of data store you're using, because those things demo great and they never work in real applications. So our aim is to take the common concerns that make sense on all data stores, like having a DB context that represents a session with the data store, tracking the changes and then handing those to the data store to persist, the concept of having a link query provider that is handed off to the data store to translate into native query syntax. That stuff will be baked into the core. And then other stuff that does not apply to all data stores comes in as a set of extensions when you pick the provider you're targeting. So the example I normally use for this is if I'm targeting something non-relational, like Azure Table Storage, I need to do things like configuring the row and partition key for each entity. That would be an extension method that comes in when I target Azure Table Storage. If I'm targeting a relational database, then I care about things like configuring cascade delete and column table mappings, and those come in as extension methods when I target any relational provider. And just to give you some examples of what we've been working on, our team has been working on SQL Server and SQLite providers, and we've also been working with the NPG SQL folks on Postgres, and then there's a whole bunch of other people who are in the earlier stages of looking at providers for EF7 as well. In addition, our team has been prototyping Azure Table Storage and Redis providers. These aren't included in our current pre-releases. We've just been prototyping them, so we're not ready to ship them yet, but we are planning to ship them further down the road. And then we've also built an in-memory database, or an in-memory provider the point of this is not to use in a production application, but if you have a part of your application that you want to test against Entity Framework, but you want your tests to run quickly rather than hitting a database all the time, you can flick out for the in-memory provider, and it will behave, for the most part, like a relational provider and allow you to easily test against Entity Framework. Obviously, that's not going to be what most people would do for true unit testing, where you want to hone in on one piece of code and test that, but it would be useful if you want to do something that's a bit more like a scenario test of an MVC controller or something and actually see it hit Entity Framework and get data back. So in addition to new platforms and new data stores, EF7, we're taking the opportunity to kind of reinvent or rejig the core of Entity Framework. So we want to make the core components that EF builds over much more lightweight and extensible. So I want to be clear here, the top-level experience is still Entity Framework. You still derive from a DB context, you expose DB sets, you have the same top-level APIs that you're used to in Entity Framework. Under the covers, though, when we talk about the core, we're talking about things such as the metadata system, the object model that actually keeps a track of what your entities look like, how they map to your data structure or your data store and all those things. We're talking about the internal components that keep a track of changes to your objects as you manipulate them in memory. We're talking about the under-the-covers pipeline that translates your link query into something that can then be translated into store-specific query syntax. So even though things like change tracking are on the list, we're changing the core components that change those, but the API from DB context, like dbcontext.changeTracker, the API still looks almost identical to what it did in past releases. Even though we're changing metadata, the Fluent API for configuring your model still looks almost identical to what it did in the past releases as well. So why redo the core? Some of the main reasons, obviously because it's extensible, you can replace or extend the components. Now this could be something you do. It also makes it easier for third-party frameworks to hook into Entity Framework and add additional value. An example of this being Glimpse, which is a logging and diagnostics plugin for ASP.NET. They had a really hard time plugging into EF6, and with the architecture we have in EF7, we're making life a lot easier for them, which will hopefully help our ecosystem with better tools and plugins available. It was also an opportunity to replace confusing APIs and behavior in our APIs that just didn't make any sense. I don't know if anyone in the room's ever used our metadata API from previous releases of EF. If you have, I'm sorry. But in EF7, we're making it so it actually looks like an API that maps CLR classes to a data store. EF6 core was built in a very monolithic fashion. The code base is about 20 years old, so we've squeezed a much better perf out of the later releases of Entity Framework, but there wasn't a whole lot further we could go with the core. This core that we're building is optimized for memory and CPU usage, and this is particularly important as we move to cloud computing and devices. On devices, resources aren't super abundant, and in the cloud, we pay for the resources we use. So less CPU can actually mean less billing at the end of the month, which is good for you. And then another concept we tried to embrace as we built this is pay-per-play. So if you use Entity Framework to target something that's not a relational database, the relational parts of the stack are separated out into a separate assembly. They won't get installed into your project. They won't get loaded up into memory when you run your application. You just pay for the bits of EF that you actually use. And then, of course, a new core means we can also implement some features that were incredibly difficult for us to implement on the old core. So this is just a list of some of the things that are new in EF7 folks have been asking for a long time. Some highlights off the list. So batching up of commands during save changes. We don't send one command to the database for every row that you change. Allowing parts of your link queries to be evaluated in memory, and some of the other things on the list there too. All right, so I promised the slide section was going to be short, and that's it. We're going to drop out and start looking at some demos. Now, before we actually start digging around in the new features, I just want to introduce you to the organization we're going to be kind of following along for the series of demos I have. So the company we're working for is called Unicorn Store. These guys are an online retailer. They have this public-facing store where you can shop around. as you might expect, Unicorn Store allows you to purchase everything that has pictures of cute little unicorns on it. EF has a history with unicorns, which if you want to know about, you can come up and I'll explain to you at the end. All right, so this public-facing website is implemented using ASP.NET 5. So let's swap to Visual Studio. And we have an ASP.NET 5 application. If we look at the references for this, or the NuGet packages, we'll see that we have, we want the installed ones. See that we have entityframework.SQL Server installed. So this is the SQL Server provider because our application we're working with targets SQL Server. Now, this is actually an important point because historically, the SQL Server provider was actually built into the core of Entity Framework. So if you installed the Entity Framework package, even if you were going to target Oracle, you still had the SQL Server assembly there. It was loaded into memory. Now it's split out, and SQL Server is really just another provider. So let's look at the models we have. We actually have two models here. Just zoom in for you a bit here. So we have the ASP.NET Identity model. So this is the default model that is there when you create a new application. It manages the logins for this application. I've actually also extended it to include things like addresses for the users and some other information like that. And then a little further down, we have the actual Unicorn Store model here. And this represents the product catalog, the categories that the products belong to, when people can put stuff in their cart and place orders and the shipping details for the orders and everything like that. Now, just to prove that Entity Framework still looks the same in EF7, if we load up one of our entity classes, it looks exactly like what we'd expect. It's just a simple POCO class, has properties with getters and setters on it. And then if we look at our context, we'll see that we're still inheriting from DB context. We're still exposing a DB set for each type in our model. And we're still overriding on model creating to provide some additional configuration based on what was discovered by convention. All right. Hopefully that gives you a brief intro to the application we're going to be working with. Let's start digging into some features of EF. So the first thing I want to do is look at logging in Entity Framework 7. It's probably not the most exciting demo to start with, but I want to show you some of the SQL improvements that we've made, and the best way to do that is to start by implementing logging so we can actually see what's happening in the database. So we'll swap back to Visual Studio. I've made a start on the logging code. I have this SQL logger. The intent of this component is to log any interaction with the database. So I want to find any SQL statements being executed and log them out to a file. You can see it implements iLogger. Now, one important thing, iLogger is not an Entity Framework specific type. This comes from the Microsoft.framework.logging package, and it's used by Entity Framework. It's used by ASP.NET 5 and all of its components, and hopefully used by other frameworks in the future too. The core of the iLogger interface is the log method. Now, in the past, in a log method, you might have expected just to get a string to log. But log here is actually a bit better than that. We have the ability to pass in state. So this gives us what's called structured logging. So if I'm about to send a command to the database, I don't just have to send you a string with the SQL in it. I can actually give you the DB command, and then your logger can do something intelligent based on what's passed in. Now, rather than giving you the DB command, we'd probably actually just give you a DTO object with some of the information copied out of the command, because we don't really want to be manipulating stuff from the logging framework. But you get the idea. I'm not just getting strings. I can actually get real information. But in some cases, like my scenario, I actually do just want a string. So the last parameter we give you is a formatter, which takes all the information I just talked about and turns it into a human-readable string. I should also mention that the exception comes in here. So another example of what I can do, if I could check and see if the exception's not null, and maybe it's a SQL exception, I can run some extra logic to log the fact that a SQL exception happened, and I can actually get the properties that are specific to a SQL exception. We don't want to do that, though. We're just going to run the formatter to get the message. I'm using a string.format to turn it into something a little more pretty. And then we're just going to go and write that out to a file in my C temp directory called database.log. Now, logging doesn't stop with the iLogger. There's actually one more level above that. There's what's called a logging provider. So if I open this up, what happens is that every component in Entity Framework, and I mentioned that Entity Framework's much more modular now, every component asks the provider for the logger it should use. So this gives me the opportunity to give a different logger to each component. So in my case, I'm only interested in giving the SQL logger to components that are actually going to produce SQL. And so I've got a list here where I've stored the names of those. The batch executor and the query context factory are the two things that produce SQL in EF7. So I'm going to check if the component requesting this belongs in that list. So the name of the component that's requesting a logger. And if it is, I'm going to return one of our SQL loggers, like so. And if it's not, I'm just going to return a null logger. And this is just something that's not going to do anything. It logs nowhere. All right, so I could go ahead and register this logging stuff directly with Entity Framework, but I'm working in an ASP.NET 5 application, and ASP.NET 5 has the concept of dependency injection baked right into it. So instead of registering my provider directly with EF, I'm going to go to Startup, where all my services are set up. If we just scroll down a bit, we'll see that my DB contexts are being registered with the dependency injection container. Now, this is important. It means if I have a controller that needs to use one of the contexts, I don't new it up in the controller. I can just ask the dependency injection container for the context, and it will give it to me. The other thing that's important with this is it also means the context can make use of any services from the container. So I'm going to register my logger with the DI container, and then all of that will take care of passing that into Entity Framework. Now, of course, if I was running in a WPF application and I didn't want to use dependency injection, I don't have to do it this way. If I don't use a DI container, EF will just take care of newing up the services it needs. So we're going to scroll down a little further, and we'll come down to where we're actually setting up the loggers. So we're going to add a provider. Finish this bit, and then I'll restart VS because I seem to have lost IntelliSense. So we'll add in our provider there. We'll run our application now and see what happens. So you notice I can register multiple providers. So if I ran this application from the command line, then I would get output from the logs streaming straight out to the console. But I also have my SQL logger registered too. So let's just browse the store, and great, everything seems to be working. And let's just go open up that log and swap the language to SQL, because that will just give us some nice syntax highlighting. And I'll zoom in for you guys because I know the screen's not great. So you can see that we're now getting all of the SQL statements that EF is running logged out to this file. All right, just give me a sec to close VS, and then I'll swap back to the slides for a sec. See if we can get our IntelliSense back. All right, while that's reloading, let's go back over here. All right, so the next demo we're going to look at is some of the SQL generation improvements we've done. So we want to look at some improvements we've made in the save changes pipeline. All right, I'm just getting VS back up and running. Just going to get us online too, because I'll need to log back into the application. All right, so let's just run our app. And I want to show you a part of the application that I'll get when I log in. All right, so I'm just going to log in. All right, so the credentials I just logged in with happen to be an administrator in the Unicorn store. And so I get this section of the application where I can do things like managing the products. And the other thing I can do here is a bulk price update. So I can pick a category in the store, let's say kitchen and dining, and I can say we want to give like a 25% discount across all products in the application. And then I press save, and we'll see at the moment it doesn't do anything. We can see listed on the screen here that the current price is still the same as MSRP at the moment. So let's go ahead and implement this functionality. We'll swap back to Visual Studio, and we're going to go into my controllers and open up the Manage Products controller. So this is a controller that drives that admin section that I was just looking at. We have an action on here called bulk price reduction. And you can see we're going ahead, we're loading up all the products from the database that are in the category that was selected. We're calculating the discount. We then need to go and apply it. So we're going to say product.currentPrice, and we're going to set that to the recommended retail price minus the discount. And so we're going to loop through all the products and do that. And then once we've finished setting that for all the products, we'll go ahead and call save changes. Let's go run the application. We'll go to the bulk price reduction. I'm going to pick on kitchen and dining again. Let's give a bigger discount. Let's make everything half price. I'll hit save. We'll see it actually worked this time. Now, in Entity Framework 6, what would have happened is I would have changed the current price for all those 4 products. I would have called save, and then we would have sent 4 round trips to the database. What we'll see if we go back to our log is, if I zoom in for you, probably. There we go. We'll see that everything is kind of batched up into a single round trip to the database. Now, you might be looking at this with an update and saying, well, that's great. Do you just always append all the actions together? And if I do 4 inserts, am I just going to see like insert into blah, insert into blah? And the answer is no. We're actually quite smart in how we build the batch. So if I was inserting 10 products, I would see insert into product, the columns I'm going to insert into, and then I would just see 4 value line underneath it that list the values to insert in. We also have a lot of smarts in there. We obviously do topological sort to make sure that the parent objects get inserted before children. And in some situations when we need to, we break it up into separate batches as well. That could be based on either the need to get values from the database before we can insert the child records, or even just the batch size. There's an optimal batch size to run for different database providers. Now, that's a feature that people have been asking for a long time on Entity Framework 6. It would have been very expensive for us to do there, but it was easy for us to bake in from the start with a much more extensible core. All right, so the next demo I want to show you is actually another SQL improvement as well, and that's when I run raw SQL queries against the database. So let's swap back to Visual Studio. We'll go to our application. And I've got a search bar here, or a search box on the top. I might want to search for shirts. And if I search for shirt, you'll see I don't get any results back at the moment. So let's go look at the action driving this. That would be on the shop controller. There's an action called search. We'll see at the moment we're not actually returning anything from the results. So from my DB context, I could look at the products DB set, and then I could write a link query here. I could say where the title contains the term, or the description contains the term, or it has a picture with a tag or a caption that mentions the term. But that's probably not going to be the most efficient way to do it. I probably want to use something like full text search or some other database optimized feature to do the search. And that's actually exactly what I've got. If we go to Server Explorer and we look at the database we're targeting, you'll see I have a table valued function here. It accepts the search term. And then the result set is just the columns out of the product table. Now, Entity Framework doesn't have the native built-in ability at this stage to call it TVP. So instead of using link, I'm going to use this from SQL method. And this is similar to what we had in EF6, so we'll just punch in some SQL here. We'll call our TVP. We need to pass in a parameter. Now, I'm not going to do string concatenation here because that would make me vulnerable to SQL injection attacks. So I'm going to use a parameter. And then we make things nice for you here. You can just pass in the actual value, and we'll take care of wrapping it up in a SQL parameter for you. So I'll run this. And this isn't earth-shattering. You could, oops, P0, not PO. That might work better. So we'll just make sure the basic functionality is working, and then we'll take it a step further. So I should be able to search for shirt now, and I can, and the shirts come back. OK. Now, what's interesting is the stuff is just coming back in whatever order it came from the database, and my TVP doesn't do any sorting in it. So maybe I want to display the cheapest items first, because I know in the context of the store, those are the items that people are most likely to purchase. Now, I could go to SQL, and I could say, OK, order by, but I'm using an ORM for a reason. I don't really want to be writing SQL all the time. So wouldn't it be nice if I could just start composing on top of this using link? Like that. Now, this is, of course, strongly typed. If I change the names of the properties, I'm avoiding all the pitfalls that would come with writing SQL. Let's run this. Search for shirts again. And we'll see that now they're ordered. Let's go look at the SQL it's running. I'll zoom in here. You'll see the piece of SQL that I specified in the middle there. And then because it's something that's composable, we're able to wrap it and add extra SQL around it. So we're selecting out the columns we expect and ordering by the current price. All right, so the last thing that I wanted to show you was something called, well, it's not the last demo, don't stress. The last bit of this set of demos I wanted to show you was something called shadow state. So historically in EF6, if you wanted something to be part of your model, it had to be a CLR class, and it had to have properties for everything that you wanted stored in your model. The concept of shadow state is the ability to have stuff in your model that's not actually represented in your CLR classes. Now, this can be useful in a number of different scenarios. It may be that the class that you're using as your entity is something you don't own. It comes from a library that's just an assembly, and you therefore can't add stuff to it. Or it could be that it's stuff that you want to kind of reason about with EF, but you don't really want to expose in your CLR classes that the rest of your application is built over. So we're actually looking at that second scenario. What we want to do is add some information to the cart items that people can add. So when I'm shopping around, I add an item to my cart. We want to track the time that each cart item was last updated. Now, the reason we want to do that is if something's just been sitting in somebody's cart for a year, they haven't touched it, we want to both clean it out of their cart because chances are they don't want it if they come back to the site. And also, we just want to free up the space in the database. Now, what I would traditionally do here, obviously, is go to my model. I would load up the cart item class, and I would add a property called last updated. I don't really want to do that, though, because I don't want developers exposing it somewhere in the UI. So instead, I'm going to go to my context. We're going to pull up the configuration for the cart item. We're going to call .property. Now, this is traditionally where I would have put in a lambda that says which property on my CLR class I want to target, but instead I'm going to use an overload where I specify a type, and I call it last updated. And then at this point, I could chain on some additional configuration to do things like setting the column that it should map to in the database, same as if I was accessing a CLR property from the class. I'm happy with all the defaults, so we'll just leave it like that for the moment. Now, in this case, I'm using EF7 to create and maintain the database for me. So this is where I write code, and then I have the database generated, and I make changes to the code, and I push those changes to the database. And of course, in this scenario, I can do things like getting a SQL script to give to my DBA in production. I just want to call that out because sometimes when we demo this workflow, people are under the impression that that's kind of the recommended way of using Entity Framework. It's one of the two options. You can use EF to create your model and then generate and update your database from it, or it's also equally valid and equally important of a scenario to have an existing database that you generate a model from. So that's just a point of clarification. Anyway, like I said, at this point, my model is a source of truth, and I want to push these changes to my database. So I would use code-first migrations for that. Now, what I would be used to doing here is I would go ahead and run something like add migration from package manager console. But I'm in the context of ASP.NET 5. So in ASP.NET 5, I also have the concept of built-in commands. So if I go and look at our project JSON file, you'll see that I have a reference to the entity framework.commands package. And then in my commands section, I have an EF command registered. So that gives me another option of dropping out to the command prompt. And I can do DNX, which is kind of the entry point when I'm working with ASP.NET 5. And I can say I want to call the EF command. And so this gives me a console alternative for the commands related to Entity Framework. Now, at the moment, this command line is specific to ASP.NET 5. We do want to have a similar command line on other project types as well. But if you're working in like a console app or a WinForms app, you would still use the package manager console in VS. I should also clarify this is like an alternative to the package manager console. It doesn't actually work in ASP.NET 5 at the moment, but we do plan to light that up by the time we ship. So anyway, let's start using our migrations command. So you probably noticed the ASCII art unicorn come up too. I mentioned unicorns are precious to us. So we're going to add a migration. We'll call the migration last updated. You'll remember, too, that I have two contexts, so I need to let EF know which context I want to generate the migration for. So it was a unicorn store context. So it's going to look at my model. It's going to look at what the model looked like last time I scaffolded a migration and create the changes in a migration for me. So let's go to the migration folder. We'll see what it's scaffolded. Looks pretty good to me. It's just going to add a column called last updated that is of type date time 2 and non-nullable. Sounds great. We want to apply that to the database. So I'm going to run a similar command, but instead of migration add, we'll say migration apply. Okay, so when this finishes, we now have the last updated property in our model as shadow state. We have the last updated column in our database, but we're not actually using it anywhere in our code. So let's go back to the context. And what I want to do is automatically set that property when save changes is called. So I've stubbed out some code here. We're going to call detect changes. So detect changes is going to look for stuff that has changed in my CLR classes since the last time DB context checked for changes. Normally, this runs automatically as part of save changes, but I actually want to run my logic before I call the base save changes, so I need to call it explicitly. I'm then going to find all the change tracking entries for cart items, and I'm interested in the ones where the entry is either added or modified. We're then going to loop through those, and we'll say entry or access one of the properties. This could be a property that's a shadow property, or it could be a property that's part of my CLR class. And I can set the current value to UTC now. Let's run our application. I'm looking for a new shirt, so I'll buy this one. It gets added to my cart. All right, let's just drop out to our database log. And I'll zoom in for you again. All right, so here's the insert command. And so we can see that last updated is just included along with the insert command as if it was any other property in my model. And you can also see when we select, we're also selecting the last updated column, again, the same as if it was just a property in my CLR class. All right, so in a minute, we're actually going to need some orders in our database. So while we're here, let's just finish this order off. I want that. You can ship it to me here. That's not my real address. Don't send hate letters there. Place my order. And let's add another order quickly while we're here. My wife and I both love coffee, so I'm just going to order a set of matching unicorn mugs for us, because we're that cool. Ship it to the same address. And place the order. So now we have a couple of orders in the database too. All right, so hopefully those few demos gave the idea that EF7 has some cool new features coming in it too. We're not just spending the whole time rewriting the core, we're actually adding new stuff to EF7 as well. I want to switch gears a bit now and talk about the other part of the tagline, one of the main parts of the tagline, which was the new platforms part. So let's do a couple of demos that talk about new platforms. So in the context of Unicorn Store, they have a warehouse that's responsible for getting all the orders that come in, packing them into boxes, putting a shipper label on them, and then shipping them out to customers, hopefully in a timely manner. The problem is at the moment that's a paper-based system, lots of mistakes get made, and it's not very efficient. So we want to write an application to help with that. Now, a warehouse is a Windows shop. We have Windows desktops, we have a few tablets around, and we give a lot of our employees a Windows phone to use. So we want to write an application that is usable across those platforms. So of course, what we want to do is write a Windows 10 Universal Application Platform app. So we're going to swap back to VS. I've already made a start on the application. So the first thing I'm going to do, well, before we start on it, let's just talk about how this application is going to work. The application is going to talk to a central web API service. It's going to ask that web API for all of the current orders that need to be fulfilled and shipped out to customers. When it does that, it's going to display them on the screen, and the warehouse worker can go through and tap the orders that they want to fill and then assign them to themselves. It will then talk back to the service and in the central database and say, these orders are currently being packed at that point so that no other employee tries to pack them as well. Now, at that point, we want to take a copy of the order information and store it locally on the desktop, the tablet, or the phone, whatever we happen to be working on, because our warehouse is a big building. It's all full of metal and a whole bunch of other stuff, and there's dead spots where there's no cell network or Wi-Fi or whatever. So we need to be able to work offline while we pack the orders. And then once the order has been shipped, at some point, we need to record back with the central service when we're online that the order has been shipped. So the communication with that web API service is done through this Unicorn Store service thing that I've implemented here. So we have a few things here. We can get the pending orders, which will give us back a list of orders. You'll see I'm just hitting a simple web API endpoint here. We can record the fact that I'm packing orders, again, just hitting a different part of the web API. And then I can also talk back to the service and record when I've shipped an order. In the moment, this service is just running on my local machine because I'm developing it. You see it's here hosted on localhost. All right, and if we go look at the model I have here, you'll see I have some simple POCO classes that are returned from the service. I have this order, and I have an order line as well. Now what I want to do is when I get that information back, I want to be able to store it somewhere locally on the device. Now, obviously, the default database of choice when I'm talking about devices is SQLite. So let's go add a NuGet package. We're going to install entityframework.sqlite. So this is the SQLite provider for Entity Framework. Good with the license. And then I've got the start of a context here. You see I've got an orders context, inherits from DB context. It has a DB set for the orders and order lines. I'm just reusing the same DTOs that were returned from the service. And now that I have SQLite installed, I can just go ahead and say options, use SQLite. Use SQLite being an extension method that's now available because I have the SQLite provider installed. Now I need to provide a connection string. And I've already got a bit of code on the line above that will find an appropriate file name to use. Now, the choose orders form is the section of the application where the users can choose the orders that they want to work on. So it's mostly implemented, but all I need to do is take an offline copy of the data once they've selected the orders. So I've newed up my context. I'm looping through the orders. I'm going to go ahead and on the orders DB set, add each order to that. I'm also interested in the order line information. So I'm going to add each of the order lines. And then once I've added all of that, I'm going to go ahead and call save changes to flush those changes out to the database. All right, let's run it and see what happens. So you'll notice to start with, I've got the target set to the local machine. So this is going to be the desktop version of the application. I can click on choose orders. It talks to the service. I get the orders back. I'm going to say I want to fulfill that one. It's going to tell me that the order was assigned to me. I'm then walking around the warehouse. This one's an easy one. So I say I've packed the T-shirt, write out the shipping label, stick it on, and then record the fact that I've shipped the package. All right, and if we go look at our website, under my account, I can go look at my orders. And we'll see that indeed the first order there is now marked as shipped. And of course, because this is a universal application, I can switch my target to the phone, go ahead and run the application. We'll deploy it off to the phone emulator. Oops, missed it. So there's one order there remaining. I'm going to select that one and assign it to me. Now, the nice thing about the phone emulator is I can actually simulate offline. So let's go take the emulator offline. Just to prove that I'm offline, I'll try and request the orders again. You'll see here it's telling me that it could not connect because the phone is offline and can't talk to localhost on my machine. But we can still go through and fill the order. So we'll pull up the order. We're going to pack the blue mug and the pink mug, write the label and ship it. And you'll see I get a notification telling me that I've marked it as shipped locally, but I couldn't sync that with the central service. So I could do that later. And so let's just bring the emulator back online. And we'll hit the sync button. And all shipped orders, we'll see now, are marked as recorded in the central database. Great. And I'll just go refresh this page. And again, we'll see that both our orders are marked as shipped now. So we're using Entity Framework with SQLite on phone, desktop, and tablet to take care of storing local data. Let's keep going with the new platforms one. So there's another part of our business at Unicorn Store, and that's the graphic design department. Now, they have this really old system that they use for tracking work orders. So when someone in the Unicorn Store organization wants a new piece, like a banner ad for the website or something, They contact the graphic design department, they go enter the work order into their system, and then their designers can take notes against that work order as they go. Now, the graphic design department doesn't use Windows. They're running on OS X. So as you might expect, the original application was developed using OS X. Now, we want to write .NET because we're a .NET development shop, but the idea of going and putting a Windows machine on their desk just to run this application doesn't really appeal to the graphic designers. It also doesn't appeal to the CFO of Unicorn Store. So we're going to use .NET on a Mac. Now, you also might expect there's an existing application that has an existing database. And that existing database is probably not going to be SQL Server if I'm talking about a Mac-based system. So it's actually Postgres. So we'll look here. I have a Postgres instance that has a very simple schema. It's probably a little hard to see on the screen there, but we have work orders and notes. Of course, this has existing data in it because it's an existing application. I can't just go and move this database to a SQL Server because we're going to do an incremental rollout of the new application. So we need to have the existing old application talking to the existing database and our new one talking as well. So at this point, I want to start writing .NET code on a Mac using EF to talk to this Postgres database. Now, the tool I choose here is not important. The point of this demo is that I can use Entity Framework anywhere that I write .NET code. I could use Visual Studio Code. I could be targeting .NET Core. For me, I've actually chosen to use MonoDevelop, and I'm going to write a Cocoa front end that uses EF to talk to that Postgres database. So I'm using the MonoDevelop part, which is now rolled into Xamarin Studio. You'll see that I've made some progress on this application. Now, I obviously need a provider to talk to Postgres, and so the guys from the NPG SQL project have very kindly worked with us on a very short time frame to build out or to port the NPG SQL provider across to EF7 for us. Now, this isn't a demo you can try at home, because you'll notice if you look at my packages, you probably won't be able to see that on the screen, but if I look at my packages, I don't have the entity framework.npg SQL package installed. What I actually have is some binaries that the guys on the project kindly provided to me that are linked directly into my application. So the package will be coming later. For the moment, just treat this as a preview of what you will be able to do very soon. All right, so I've got some POCO classes here. I've got a note, I have a work order class, and I've got the start of a context. You're used to all this code by now. The only thing I have to do is wire up the context to point to my database. So obviously I'm using NPG SQL provider, so I can do builder, use NPG SQL. This is an extension method I have because I have that provider installed. I already have my connection string stubbed out there. And so now our context is hooked up to our Postgres database. Let's just go look at some of the code we have in the controller for the main window. I guess I should point out at the top, I'm creating an instance of the context that's going to live for the duration of the window. Here I'm using a link query to pull back all the orders for the user that's currently logged in. In our demo, it's going to be Jeff that's logged in. When the user selects, or when Jeff selects a particular work order, we're going to go ahead and use another link query to load the notes for that work order from the database. And then when the user tries to add another note, or when they do add another note, we'll create an instance of the note class, we'll add it to the notes DB set, and then go ahead and push that out to the database. Let's run. So we see the work orders coming up on the screen. One of the work orders here is an ASCII art unicorn. We'll see there's a few notes here. Jeff's discussed something with Amy. Rowan suggested that we should just steal the ASCII art unicorn that the EF team made. Jeff thinks that's a stupid idea. And then just to prove it's actually working, let's go back to our Postgres database. We'll look at the notes. And we'll see that new comment that I just entered is written out to the Postgres SQL database. Yeah, you can clap for that. Come on. All right, just give me a second. I'm going to do something here to get our next demo ticking over while I talk. How many people in the room have seen the unicorn clicker demo that I've done before for EF7? Nobody? OK. you've been missing out. Unicorn Clicker is this very cool application that Unicorn Store does because Unicorn Store wants to cash in on this whole craze of having very simple, not very sophisticated games on our phone that tend to occupy quite a lot of our time. What they want to do is have this picture of a unicorn flashes up and you click it as many times as you can in the allotted time and it keeps track of your scores. And it sounds really lame, but people are going to spend hours when they should be sleeping clicking the picture of the unicorn. And of course, when you open the app, it's going to have some not so subtle advertising that says, hey, you like unicorns, you should come to our website and check it out. Now, our marketing department wants this to run on all platforms. So they've heard about this cool product called Xamarin Studio and Xamarin Forms, which should allow us to do just that. That's not the one I want. I want this one. All right, so here's a Xamarin Forms application. I'm going to stick on OS X for the moment, just because that seems like the cool thing to do. So I've got Unicorn Clicker here. I have a model. I have a game class. That's a simple game. I have a context. And then if I go look at the implementation, the game page is where I actually click the picture of the pretty unicorn. And so if I look through this, you'll see when the game finishes, we create a new instance of the game object. We add it to the DB set on our context, and we call save changes. And then we have a score history page here. So I load up the games. I want to get the ones with the highest scores. I want to take up to the top 5 of them. And then I go and bind it to the UI. So I'm going to run it. It's going to fire up in the iOS emulator. We'll see our UI with the not-so-subtle advertising to visit the Unicorn Store. We'll click play. We have 5 seconds to click the unicorn as many times as we can. 25 is, oh, yes. Wow, cool. 25 was my top score. And, of course, we can go to the scores page, and there's the data coming back via Entity Framework. So that's Entity Framework running on iOS in a .NET app written with Xamarin Forms. Cool. All right, I'm just going to hop back online with this guy. So we've got a few minutes left. I just want to wrap up by showing you some resources that you can head to if you want to learn more about EF7. So let's actually flop over and I'll show you some of them, because we'll flick back over to my desktop. All right, so Entity Framework 7 is open source. Entity Framework was open source in 6 as well. Used to be on Codeplex. EF7 is now on GitHub. Now, we're not just open source as in you can look at our source code, but we're properly open source. Our issue track is public. If you go to our wiki, one of the interesting things you'll see here is we actually have design meeting notes. Now, we've had a bit of a period where we've been pretty light on the design meetings. Oh, I guess we had one here recently. When we have design meetings, we take notes and we publish them up on here for people to give feedback on. So we're kind of inviting you into the development cycle before we even get to writing any code. So here we're talking about the layout of code when we do reverse engineering from an existing database. At this stage, this is also the place you want to go to for getting started information on EF7. So if you want to get started using EF7 in a traditional .NET application, you would come here, and it'll tell you what release you should use and how to get started and all those things too. I should also mention we're open source and we do accept contributions. Obviously, we have a fairly stringent process for code reviews, and we expect you to write unit tests and everything too, so we don't just accept any change that people want to give us. But we are open source, and we do accept contributions into the product, and we have had a few great contributions from the community. If you're not quite so interested in getting involved at that level, but you want to know more about EF7, then this link is on the slide, but it's aka.ms/aboutEF7. Zoom in, that one, which will redirect you to a page where we have a link to what EF7 is, but then also a series of blog posts and other information we've done where you can dig into the new features that are coming in EF7 and the changes to the core and all those types of things there. don't worry about remembering all these URLs. They're in the PowerPoint for the deck. The other thing that you might be interested in is the demos I showed looking at the code I actually used to do them. So we'll go to my GitHub account. Just zoom in for you again so you can see roughly where I am. Again, the link's in the deck, so don't worry about it. You can get the deck online afterwards. But my GitHub account has the Unicorn Store code on it. And you'll see here I have the completed source from the demo, and we have the source code for everything we looked at here online. All right, there's everything I just showed you linked on the slide. So I actually wrapped up with a few minutes to spare, so I've got time to take a couple of questions. If you have questions, I'm going to ask you just to step up to the mic. Probably just time to take 2 questions. So if someone wants to jump up and ask a question, please go ahead. Yeah, question. You can ask and I'll repeat. Yep.
I don't know if this makes sense, but is there any plan to have a no data provider for Entity Framework 7?
Question was, does it make any sense to have an OData provider for Entity Framework 7? Not sure. It's something we've actually talked about. It is interesting because often with OData, you're getting data from a database using Entity Framework anyway, and so putting an EF provider on top of it. It's not something our team is probably going to implement, but it is something that somebody else I could see outside of our team working on in the future. Cool. Yeah? Oh, the question was, is EF7 going to support inheritance? Folks may have seen in our announcement posts up until now, we've said things like inheritance is not supported. We had a stage where transactions weren't supported, but they are now supported. So yes, inheritance is actually a work in progress in our current code base. Actually, some of the APIs are there in the beta 4 bits that are available online now, but it's not wired right throughout the stack. So inheritance is coming, it's just not there quite yet. What we're implementing at the moment is a subset of what was in EF6. I'm not sure that we're going to build everything that was there in EF6 into the stack, because one of the things we don't want to do is support all the insanely crazy mappings you could do in EF6, but certainly a lot of the patterns you could do in EF6 will be supported. All right, got one here.
Is there a way to generate models in different projects?
Is there what, sorry?
A way to generate models in different projects?
To make models in different projects?
If I'm using database first,
yep.
Entity Framework will generate the models for me, right?
Oh, yeah. So can EF make models for you?
In different projects.
In different projects.
Yeah.
So do you want the classes spread throughout different projects, or you just want to tag?
For example, if I'm using them in MVC, I want the attributes.
Yep.
But if I'm using them in a Windows Phone or Windows 8, I can't use the attributes.
Right. So you could put your model. Your model can be in a different assembly, if that's what you're asking, or a different project. So you could do a portable class library that has your project in it, your model in it. You could also cross-compile if you want to have attributes, and you could put attributes and put some compiler logic around them to strip them out. What I would recommend doing that if you want to have your model available on a platform that doesn't support attributes is just do your configuration using the Fluent API, because that is available everywhere. Cool. Yep.
In a database-first approach, Entity Framework 7 will support views.
Question is, will database first, so generating from an existing database, support views in EF7? It doesn't at the moment. It would be extremely easy for us to wire in. We're still playing around with the process. At the moment, it's just a command line process, and it's kind of a all or nothing thing. You point it at the database, and it generates for all your tables. We are going to build a UI that's kind of like what you're used to in EF 6.1, where you can point at an existing database, pick the views and tables you want. I can't see any reason we would not include views in that dialog and the ability to select them. All right, I'm going to take one more question. Yeah. Yeah.
You can select the view, but it has some problems detecting the primary key.
Oh, yeah, so the question was, when you select a view at the moment in reverse engineer, we generally just make every property in the view the primary key. We won't be doing that when we do reverse engineering for views in EF7. The reverse engineer process is a completely new thing, and we'll do something sensible in EF7. The EF6 is great, but yeah. All right, I'm going to thank you very much for your time. I am going to ask you to, thank you. Filling out session evaluations is extremely useful to us. It helps us get better as speakers, so please take the time to fill one out for this and the other sessions you attend. Thanks.